Joshua, just to confirm, yeah, still typing, yeah?
Just finished.
Okay, sure. Okay, you're looking at Ang Mo Kio, right? Then, oh, wow. Okay, that's a bit short. Oh, okay, got it. There should be some difficult questions and some topics that you have not seen before, obviously, yeah? Oh, wow, yeah. Not the easiest one. Not the... Remind me, Anu, which school are you in?
Swiss Cottage.
Oh, yeah, should be around there. Okay, I'm reading it. Joshua. Oh, wow. Okay, Joshua. So let me confirm this. Before the test, if I'm not mistaken, you think that you might not pass. Am I correct? Before the test.
Yes. I just went in there. I'm just hoping that like I get double digits. I don't know if I didn't hope to pass.
Right.
At that point, I
before.
think like passing was like out of range.
Right. That was
But
before lah, right? Before then.
turns out I got like, so I got 19, which was one mark below the passing mark, right? And then one of the questions, which was like a moment question, it asked, because one of the questions that the planks are at equilibrium, and then it asked how much moments it produced, and I said 0, and I got no marks for that one. So they decided to give me the mark, and I passed by just like 1 mark. So I barely passed, which I was like, sorry.
But then what's the 24? Then you have
That's
24?
that's my friends, my classmates.
Yeah. Oh, right. Okay.
That's the highest I've known. I've seen so far. Because from the other class who also takes physics, they got like the highest is like 22, 21.
Right. Which is definitely not very far, right?
Yeah, so it was like a hard paper in general.
And I think that must be right, huh? So yeah, actually, what I thought is that you also, I have an impression that you also think chemistry won't pass. I might be wrong. Before the test, lah. Is that correct?
Like
chemistry?
I mean, no. First, no, because I think what she gave was like way harder than the practice papers were all like quite complicated.
Oh.
And then when she gave, it's like, oh, that's quite simple to do actually. So I was like, after seeing the paper, I was quite disappointed that I only got like like B3. I should have like, because of the careless mistakes and all.
Right. So there's that reversal lah.
Yeah. But I think like one of the questions which like got me into B3, I think like I wasn't really familiar with that one, so that was like kind of on me as well. Yeah. Because like I didn't revise that one a bit more.
Right. So you were telling me that your chemistry teacher seems back then before test seems to be giving you the right difficulty regardless of the teaching ability right? something like that.
Yeah.
right?
Yeah.
So that turns out to be more than enough, lah. Right?
Yeah.
So,
So
good.
she's really getting better now, like
Oh.
explaining really well. So
Wonderful, wonderful.
Yeah.
Okay. All those good stuff, and we can count on the practice level lah. We can count on that lah.
Mm.
Right. Okay. Good. Good. That's all good stuff. Right. And then for physics, what do you think? Is it still like, yeah, the practice wasn't enough lah?
I think so. I don't know. My physics teacher is giving me like 3 practice papers, which she arranged herself, and then she wants us to do all of it for the holidays. So I think
Okay.
I'll see like whether it's good enough.
Okay. Okay. Understand. But I guess still congratulations lah. Right. Good job. Yeah. Feel free to be disappointed with chemistry, but that means you still did all the correct things lah before the test. It feels that way lah. It feels that you did your best lah. It does feel like that. Okay. Of course, there'll always be careless mistake, and we will try to fix that lah. Okay. Good. Anything else you want to share with?
I don't think so. Just
Alright.
just that.
Okay. Now, how do you feel today? I mean, you sound quite tired.
I mean, like it's just a bit burnt out lately because of so I went for a camp, right?
Yeah.
It's like it's like some sort of STEM camp where I have to design a product and stuff, and then design a building. So the past like what 5 days?
Yeah.
So I had to live there. It was a boarding school.
Oh wow. Okay. Right.
Yeah. So they keep on releasing us quite late and stuff. Yeah. So I keep on sleeping quite late, and yeah, but it's fine. I think it's okay. It's okay. So a bit more. I think I'm down to just do a little bit of physics, a bit more, just before
just before you rest. If it is just a burnout, that means tired, like then of course, the only thing we can do is rest. That's true.
Yeah.
If you're okay for today, then we'll take it slow, and since there's physics homework, we'll just do it.
Okay.
Right. And no, never mind. Not much analysis today. Okay, I'll just follow you in your homework. Right. Okay.
Do you mind if I take it? I think I got like the wrong one.
Let's go. No problem. Okay. So for you, Anu, so what do you think about the paper? Yeah, I asked you to survey and all, right?
Pretty much okay, and then the hard questions are really extreme though.
Give me an example of what you think is hard.
Oh, question A.
Paper, sorry, which paper? Paper 1.
I'm okay. Yeah, paper 1.
Okay, let me see. Wait, question 8. Question we will call this the tree and stem and leaf. This question, the stem and leaf diagram.
Yeah.
Oh, good news for you. This is one of the easiest one if you understand. Good news. Maybe you just haven't covered this. Maybe. Nice. Okay, good to know. What else seems difficult for you?
Question 9 we haven't looked at yet, but it looks very difficult.
Nope. Good. All right. Then which one? What
sorry?
else? What else looks challenging, I guess?
I don't think we have learned question 12, so that
question 12. Let me confirm this in your mensuration. That means, cube and stuff. You have not learned pyramid.
no.
Okay. Then if I tell you something like this, remember the formula for volume of prism from secondary 1? Do you remember that? That's you haven't done this for a long time. Must be right? Prism. Okay, then let me refresh your mind. Prism, base area times height. That's how usually your teacher did.
Yeah.
Okay, something like that. Okay, so now a pyramid is of course not a prism. Let me refresh you. Sorry. Let me refresh you what a prism is, right? Okay, so I copied the question to the Jamboard. Which Jamboard? I'll make a Jamboard for us.
I already shared it with you.
Oh, okay, wonderful. Okay, let's do that. Okay, I'm in. Oh, you asked me something. Sorry. Let me answer that. Sorry, let me answer that. No, let me answer that first. Sorry. So what do you mean by references? You mean more practices, isn't it? Is that what you mean?
Yeah.
Okay, let me give you my reasons and my recommendations, right? So at this stage, my recommendation is to jump right to the end of year papers. The reason is very simple, because all the hard topics, all the hard and necessary topics are done by term 2, which is we are done right now, no? And you don't seem to have a lot of problem, judging from your last exam. So when we jump to the end of year, you will have, this topic haven't covered, this topic haven't covered, this topic looks difficult, but all of those topics are the easier one. Doesn't mean that you can do it right now. Doesn't mean that. So of course you cannot practice them, but you can practice the remaining questions and get a very good sense of them for end of year. And then I will slowly explain what I claim to be the easier topics. For example, the pyramid one, I explain a little bit, you can do already, because there isn't much addition, for example, right? So that will be my recommendation. You don't have to deal with too much books already, probably because you'll get it faster here. If you just, listen to me for a while, you'll probably get it already. Okay, that'll be my recommendation. If you don't think that's enough, we'll discuss more. Would that be okay?
Yeah.
Right. So for chapter 9, Pythagoras theorem, that is still a very important chapter, though it is not very difficult. Do you want to talk about that today?
Actually, from what we did online, I think it's pretty much okay.
Yeah, that would be what I expect also, because the hardest topics are over. Okay, good. Expect to encounter Pythagoras theorem from now on in all sorts of questions. It is a question, that is a topic that can be implemented anywhere. Okay?
Yeah.
All right, okay. Have I answered all your questions?
Yeah.
Okay, then let me explain to you prism and pyramid. Those are the main differences of Sec 1, Sec 2. Now, I am going to draw the cousin of this pyramid. The cousin of a pyramid is, of course, a prism, Sec 1. So the base area is the same, and a prism's definition is very simple. The base area extends all the way up. That is the definition of a prism. Okay, so one more time, a prism should have the same cross-sectional area throughout. Does that make any sense?
Yeah.
So a prism's volume is easy. What you call the base area and then times the height. Okay. So how does the cousin pyramid go? The cousin pyramid is so simple. Remember, a pyramid is a prism which, terminates at a point. That's all there is, correct? The volume of such thing is simply 1/3 times base area times height. They don't tell you why, but this is always correct. Okay. Then you give you a Sec 1 prism. What is this prism called?
That's a cylinder.
A cylinder has a cross-sectional area which is the same throughout. That's why it's a prism. And that's why the volume is base area times height. So far, so good? So here's a cousin of the cylinder, which is a pyramid. What do you call this? A cone, the pyramid version of cylinder. Make sense?
Mm-hmm. Yeah.
What's the volume of a cylinder, of a cone? 1/3 base area times height. That's it,
Oh, okay.
simple application. Yeah, I'm teaching you the application now, obviously. Okay. So this thing is universal lah. This thing is also universal. That's how we do it, lah. Okay.
Yeah.
There will be other complications, but for this question, it is more than enough. Would you like to give it a try? Maybe try this question today. We're already covering the future topics, and I know they are not very difficult. Okay, mind doing that?
Yeah, sure.
All right. So yeah, right. You can erase my work to give you more space. Okay, so Joshua, yeah, I'm here, right? So, Joshua, you help me a little bit. I know you have some questions, and this is definitely a connected mess, right? Oh, no, it's
Yeah.
not moving. So if it is not moving, it's not very, it's okay lah. You want to ask
T.
D? Let me see for what? Let me see. Your logic is T1 is in more tension than T2. That's your logic, right? Which you are correct.
Yeah.
Yeah, you're correct. And yeah, I mean, you're basically correct. Good job.
Hold on, I'm a bit unsure on this one. I forgot my. I'm forgetting
okay.
my forces already. Is it like this one?
Okay.
This directions here, right?
So you're drawing the FBD and the weight
Yeah.
piece. The weight piece.
Weight is
In the middle of the load.
here.
No, middle. Like really the center.
Oh,
of the load.
okay.
That's where, yeah, that's where it makes more sense. And then W. Now remember what I taught you. This was new, even like close to the exam. Your FBD is drawn correctly, but the diagram that they draw for you is not FBD. It is a rearrangement of the forces from the FBD. So we call it the vector diagram. In vector diagram, you must obey a different rule. Remember, start, end, start, end, start, end. Remember?
Yeah.
So you must rearrange these three forces, correct, in a start, end position, and then figure out your answer lah. Now I can tell you immediately whether you're right or wrong lah. Is C right or wrong? Do you want me to tell you that? You are definitely, yes. So your mistake is you didn't start with FBD. That's all.
Okay.
Just figure out which one is correct. It'll be easy for you.
Okay. It's either B or A.
And it is easy to find out which one's correct by observing your arrow in FBD. I really don't want to tell you which one's correct. You gotta observe the arrow. It's obvious. It's obvious which one's correct and which one's wrong. Come on. Observe the arrows in FBD. One is like that. So it should exist in your vector diagram. It should.
Oh, okay. So it's just A? Is it this way?
Am I reading the arrows wrongly? Could you zoom in a bit more? I thought A is wrong. I'm sorry. Okay.
Because is it
No, you're wrong. What? You're wrong. You didn't find the two arrows of the rope in A. What? They are the opposite. What are you talking about? Oh dear. Okay. Oh, no. Okay. You gotta get this right. Okay. So first thing first, you must start with FBD because FBD is the start, not the vector diagram, right?
Okay.
Then I give you the, okay, look at your Jamboard, right? Page 3. Okay. Again, what is in FBD must exist in your vector diagram, right? So look at this guy. This guy is this guy, right? Correct or not?
Okay.
It doesn't exist anywhere in A. The red rope guy doesn't exist, right? Correct or not? It makes sense, right? And then there's a blue guy. Oh, blue guy is here. Okay, it doesn't exist in A, which makes it wrong, right? The W is here, correct?
Wait, so how do you wait? I'm forgetting a bit more. Wait, how do we know this one's not in?
Look at the direction. Like first of all, it must be exactly like pointing at the exact direction. The direction matters. Like, do you see it? No.
No. Okay.
It is as simple as that. You don't get to flip the direction. You get to rearrange, but not flip the direction. Definitely not. Right. Okay. The direction is of utmost importance lah.
Okay.
All right. Good. Right. Moving on. Right. Oh, sorry. I'm curious. I want to look at the last question. I want to know this practice paper until what kind of topic? Can you show me? Okay. Just the
So-
MCQ part. Just the MCQ part. The MCQ,
MCQ
will
part.
tell me. Yeah, yeah. The MCQ part tells you all the topics he covered, right? That's how MCQ works, right? So 20, 30. What is 30? Oh, it's still pressure.
Yeah, it's
Okay, okay.
it's until pressure.
So it is what you have learned. He is not giving you, the future topics.
Yeah.
A bit of a waste. Do you know what's the future topic? I'm just curious.
I think it's like,
The one after holiday,
is it Bernoulli's principle?
which is part of pressure, but
It's still pressure, yeah.
continuing pressure. Okay, okay. All right, all right. If it is possible, I would like to cover, a bit in advance, not today. Yeah.
Energy. Energy
Energy,
and
yeah, energy very important.
work and power.
So you haven't covered energy, work, and power.
Not yet.
Oh, very important. Okay, okay. Looking forward to covering that with you, but later lah. Okay, please go ahead. Go ahead. Continue. Okay, take it slow lah today. I know what you're doing it's really fine, right? It's really fine. Oh, he wants your pie to be okay. Sure thing. Sure thing. Okay, not a very nice number, but there's that, right? And you have the calculator to help you. All right. Beats. Okay, understand. Okay, Anu, there's no way to confirm the answer lah. It takes quite a lot of effort to simply confirm it. So we don't usually confirm it lah. Are you confident with your answer?
Not sure actually.
Right. For today, why don't we just, look at the answer key because there is no other way to confirm. Okay, are you ready? Check it out.
Oh,
How is it?
it's wrong.
It's wrong. Wait, which one's wrong?
Part
Part B. Oh, I failed to notice, right? So let me explain why it is wrong. Let me confirm that the volume of sphere you have not learned yet. Okay, so volume of sphere is a very specific formula, 4/3 pi r cubed. Okay, so that explains your error. Would you please try again? Something like that, Anu. Yep. Oh, let's stop there, Anu. You forgot that there's a cube here. You forgot the cube.
Oh, the cube.
I hope it makes sense. For a volume, you will cube the R, lah, not square the R. I hope that makes some sense. Joshua, how are things so far?
They're quite manageable actually. I can skip to the structure question if you want to like
Well,
discuss a bit more.
no, of course, but it's very surprising. Eh? So the MCQs you can handle very well, right? I mean,
Everyone in my class said, "Oh, actually, why does it feel like I can do the MCQ but not the TA2?" Yeah, everyone said, "Oh, why is it quite easy actually?" And then one of the guys who failed physics said, "Oh, I feel like I can do this better than the paper." So I don't know.
Right. Let's see whether it is true that it's easier, right? Because I am trying to sense your exam pressure level to everybody else, right? Because all of you enter physics exam with greater uncertainty than, let's say, chemistry paper.
Yeah,
Chemistry paper already a lot of uncertainty. Then physics even worse. It's just a compounding uncertainty. And that itself starts everybody at a very high pressure. You just don't realize it. The amount of uncertainty really determines the amount of exam pressure. I mean, that's the biggest factor. So I wouldn't be surprised. I wouldn't be surprised. And then suddenly here it's not exam. You have no pressure. You can think better. Let's see. Okay, your choice. You can skip to whatever you find is difficult. There would be, I mean, if you're not tired, I almost want to offer you, just a skip today. Okay, so Anu, now it's okay, yeah? Now it's correct, yeah?
Yeah.
Now, I invite you to look at I think the second page. That means you go in front of the paper and you realize there's a formula list. Would you please look at that? Hey, wait, do they give you? Oh, they don't. Oh,
It's at the start of the whole paper.
Is it? Sorry, how come I cannot find it? Wait.
It's at the start of like the whole
the whole thing, is it? The whole thing.
Yeah.
Oh, right. Okay. Yeah. Right. Yeah. This is a appropriate one for Sec 2 . Do you notice anything? I mean, all of the mensuration are new, and you notice one guy we used today, yeah, which is the volume of a sphere.
Yeah.
Okay. So you don't have to memorize it. I still recommend that you do, but it's nice to have a backup, right? Later on, right? Anyway, today is just an exposure, right? Okay, let's have a taste. Whatever you ask to taste beyond term 2, the new topics, whatever, it's gonna feel okay. It's good to taste them now if you want. Could you make a request? Maybe you want to try this guy or that guy. Let me explain to you. Right. You choose. It'll be okay for you. Maybe you always have a problem with pattern question. Yeah. Maybe you don't like the look of the new topics. Maybe you want to know, all those stuff.
Oh, will they give us the formula page in exams?
I'm sorry, you're saying? Sorry.
Will they give us the formula page in exams?
As far as I can tell, yes. But let's confirm with the teacher. Let's confirm. Because the reason is very simple. Because in O-level, the real O-level, 2 years from now, they give you, and it's a lot longer than this one. Right. So there is no reason why they don't give you, but it's always up to the discretion of the teacher. That's why I say ask teacher, what does he want? He want to give you or not? Something like that. Okay.
Oh, I already put in the page.
Let me see. That thing. So question 8, you're saying? Yeah. Okay. So okay. So 8A is a bit of warm up for us today. In exam, it'll also be like this one. It's not a very difficult thing. I have to explain to you two things only. The mode, what does that mean? And then the mean. Actually, you probably know what mean means. Do you know?
No.
It means the average. Well, that's quite simple.
Okay.
Can you calculate the average? Sorry. How would you calculate the average? Just tell me.
Add it up and then divide it by 1, 2, 3.
Yep. All right. Now, the X is a little bit more challenging, right? You have to know what's the mode first. The mode means something very simple. It means the guy which appears the most frequent.
Okay.
Right? And he said there are two values. What does that mean? It means that there are two guys who appears, at the same time, same amount of times, and that happens to be the most also. All right. So let me just give you an example. So to find mode, I will actually arrange them first. You see that they are not arranged in a nice way, right? I will do that. I think that's indispensable. I'll arrange 2 and then slash it because I don't want to miss anything. 3 slash it and then 4 slash it. Would you kindly continue for me? Good. Now, I've told you everything you need to know. Is it obvious what X is?
Yeah, 7.
Correct. And that's why he say write down. He doesn't say work it out. He doesn't say solve. He say, there's no way you just see it lah. Then it's 7, no? And you will be correct. Okay. So finding the mean is now easy, right? Done lah. Okay.
Yeah.
Okay. So we are done with here. Yeah. That's mode, that's mean, and then there's a median also. We'll talk about median when you encounter the next question, which is here lah. Yeah. Okay, so mode, mean, and median, right? Let's check it out. Now, in B, there is a stem and leaf diagram. A stem and leaf diagram is very easy to read. Let me show you. This guy means 35. This guy means 36. And this guy means 37. Do you understand?
Yeah.
Okay, what does this guy mean?
40.
Good. What does these two guys mean?
60.
And 60. Will that be okay?
Yeah.
And this W doesn't mean W is 5W lah. You just say. Okay. Now I have to explain to you what is median, and then you can answer. Okay. So mode, mean, and median. Median is the middle guy only if you order it first. That means you must order it this way. Then you can find the middle guy. You cannot find the middle guy from a disorderly thing. Get sense? Do you notice that stem and leaf is always orderly? That's the advantage. They already ordered it for you. 60, 60, 62, 63, 69. Orderly, ma? Correct? 74, yeah. 80. Everything is orderly. So he has done, the bulk of the work for us. Let's practice median here first. See how I find median. Yeah? You see, yeah? How many things? 1, 2, 3, 4, 5, 6, 7, 8, 9. If it is 9, it is guy 1, 2, 3, 4, guy number 5. How do I know?
Sorry, I can't say anything. I'll go in and out.
Go in and out. Okay. Joshua, are you okay so far? Okay. Right. Oh, things are okay. I want you to do number 3 after, right? Number 3 is the forces guy, right? Yeah. Good practice. Okay. So back to you, Anu. Okay. There are 9 items here, correct?
Yeah.
The median guy is the guy in the middle. That's it lah. the guy in the middle must be in position number 5. Do you have any question? Okay, now I'm going to alter the thing a bit. I'm going to add it into, 10 lah, 10 numbers, okay? Not 9 anymore. Now, who is the middle guy in this case? Is it guy number 5? Okay. Is number 5? Is it guy number 6? Or is it the average of guy number 5 and guy number 6 lah?
Average.
Average. So happens this is 5 plus 5 divided by 2. So it is 5 lah. But it is possible for it to be, for example, 5 and 6. So you will say 5.5, even though it doesn't exist in the original order. Would this be okay?
Yeah.
So even number and odd numbers just slightly differently for median. That's all. Okay. Now, here is 20 students. They already tell you very nicely, these are 20 numbers. The median is where? Position number?
Average of W and 7.
All right, which is 10 and 11. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. You are absolutely correct. We just have to find, oh, they tell you the median is 56, then expect you to find W. So what is it?
50 something plus 57 divided by
2 equals to 56. Not the most difficult thing.
So it's 56.8.
Does it make sense? If it is 56 and 57, the middle guy is 56.5, correct?
Yeah. 55.
Try again. Okay, the middle of 55 and 57 is 56. Make sense? Does that make sense?
Yeah.
Okay, then that's it. You are correct. He say write down. He doesn't even ask you how. Just write down. So you think a little bit 56 and 55. Make sense?
Yeah.
Okay, so as I promised, not that bad, right? Now, a student is considered underweight, blah, 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 is less than 45. I think that will be considered underweight. Oh, no, this is sec 1. Wait. That's... What? Okay, that's weird. Okay, so 45, right? 5% of students who are underweight. Okay, wait, this is not very difficult. Can you do it? Okay, give it a try. That's just a variation question. It can appear in many forms. So we just use logic. Seems okay. Okay, Joshua, you're doing the FBD. Good, right? As per usual.
30%.
30%, which is because there are 6 numbers below 45, right? 6 over 20 and 20 times 100% is definitely 30%. Okay, correct, yeah? Okay. All right, we haven't covered all the variation of this topic, but this is the basics. Are you okay? All right, let's move on. Choose another question, right? Have a taste. Okay, so Joshua, the word scale diagram means the vector diagram, which means accurate drawing. Now, you didn't have any accurate drawing. Probably no. Probably not gonna work very well. Again, You're drawing an FBD. That's good. An FBD has to be converted to a vector or scale diagram by using the rule start n, start n, start n. Because an FBD is not start n, start n, start n. Am I making any sense?
Okay.
Okay. I'm gonna copy this in the Jamboard first. If you don't understand what happened, this is because we discussed this like the day before the exam, right? So give it a try for a little bit, right? Now, Anu, this is a question that haunts some students start since primary, the pattern question, right?
Yeah.
How do you fare in a pattern question?
I think patterns is like really my worst part of math. Yeah.
Right. Good news and bad news. Actually, not a bad news. The good news is whatever the pattern is, the first few marks are always easy one. We can use our thinking and logic because it will always be different, the pattern, right?
Yeah.
Which is part of the bad news. Hey, the pattern is always different. We cannot actually guarantee what pattern will come up. We just have to deal with it. That is part of the intention of the question. That is it. You can use spot a pattern and not memorize it. Okay, so we have to accept that. But the bad news part is actually not that. The bad news part is just there's a very small part where people cannot do, but the rest people can do one. So for example, I'm very confident that you can do P and Q. Please give it a try. No new methods needed, just logic and observation. Okay, so Joshua, you're saying that you're kind of stuck, right? Am I correct? The question.
No, I couldn't do it.
Okay, so if you would look at the Jamboard, right now, first thing first, the FBD, you're supposed to focus on a certain point. So I take it that you're focusing on this point, correct? Am I correct?
Yeah.
But at this point, just to be very clear, even though the W is here, right? We know that, huh? No, W is there in the middle of the lamp, right? Now, the W will cause a certain tension, right? You say here's going up. Right? Now, this is correct if you're looking at the tension holding the lamp, right? However, if you're looking at this point, which I think is the correct point, you will feel that this point is being dragged down by the lamp and the rope.
Yeah.
Which is to say, at this point, the tension is going down, so to speak. Am I confusing you?
Okay.
Am I confusing? Right. So now we focus on tension 1, tension 2, and we'll call this tension 3, okay? Which is, in terms of value, will be equivalent to W. We'll ignore the rope's weight. Okay? Will this be okay? So NW will be 4 Newton. Would that be okay?
4?
Because 0.4 kilogram, right?
Oh yeah, okay.
Newton. Okay. So he want us to find T1 and T2. Wow, right? Using a scale diagram. Wow. Okay. So the only thing we have is the 4 Newton, which means I can do this in, I don't know, I can do this in 4 centimeter. I can do this in 8 centimeter. That's just up to me. Okay. So far, so good.
Okay. Okay.
But remember, I don't have the length of T1 and T2. I'm supposed to find it. That's what it means to determine the tension. Yeah, I don't know the length what. Yeah, I cannot draw what. I mean, you're right and you're wrong. True, you don't know the length, but you have their direction. That's the most important thing you have, yeah? Okay? As for the weight, you have the direction and the length. So that's why you can draw. So I'm going to draw that for you. Let's pretend that 1, 2, 3, 4 centimeter. That is my W, okay? Which is 4 centimeter. Okay? Now, start N, start N, start N, correct? This is my start. This is my N. The N is the start of another guy. It doesn't matter who. You want to start with T2 or T1? You tell me.
Let's say T1.
All right.
Okay.
What do you know about T1? Not the length, but the
angle, direction.
Correct.
Angle.
So I'll be faithful with it. Look, why am I drawing as a dot, dot, dot? Because it represents that I know the direction, but I don't know the length. So I just go like that. Look. Simple, right? That's T1. T1, no? Okay. And it will be like this, but I don't know until when. There, I've drawn what I know about T1. Understand?
Okay.
Now, T2. T2 must start where T1 ends, which I have no luck right now. I don't know where T1 ends. I cannot start my T2, correct?
Mm-hmm.
But I know where my T2 ends. My T2 ends here. Correct or not? My T2 ends here. Correct? Start, end, start, end, start, end. T2
Okay.
will end where W start. Why?
Okay.
Everything becomes zero. What? Everything goes back to the origin. Everything total zero. Nobody is moving. That's the whole point.
Okay.
You don't get this. You don't get this, isn't it? Let me finish it up first, yeah? So I know where T2 ends.
Yeah.
And I know its direction. I just don't know the length. So I'll be faithful to the direction, right?
Okay.
40 degree, correct? Ding, 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 ding. This is my dotted line representing the direction of T2, but not the length, correct?
Okay. Mm-hmm.
And because of that, I found my T1 length and my T2 length. That's it, no? Look at my vector diagram. Am I faithful to the length of
Okay.
W and the direction of W?
Yeah.
Am I faithful to the direction of T1?
Yes.
Am I faithful to the direction of T2?
Yep.
Did I follow start, end, start, end, start, end?
Yep.
Then I must be correct.
Okay. Okay.
This is how to do it. Try to close it and try to repeat it. Of course, you can ask questions, okay?
Okay.
Ananya, I can see you, yeah? I'm just helping out my other friends, the other students. Yeah. Can you hear me, Ananya?
Yep, I can.
All right, okay. Ananya, are we continuing with the previous slide or are we doing something new today? I'm asking. All right, wonderful, wonderful. All right, do prepare that. And oh, you have sent me. Okay, so I think I should start from there. P and Q, I agree. Wow, Ananya. Wow, Anu, sorry. Anu. Oh, you're absolutely correct. No, you're absolutely correct. Wait, Anu, you have no no, you have a problem. I'm sorry. No, I'm sorry. You do have a problem. Okay, don't okay. It's okay. It's okay, Anu. It's okay. Your problem is very simple. Your problem is very simple. You forget the principles of quadratic function. The principle of quadratic function is you must make the right-hand side equals to 0. You did forget that. That is how you can proceed. So all these are correct. This is not wrong, but this is not useful at all. Do you understand what I'm saying? Okay, once you do that, you can find K and well, congratulations, you got something, right? You did get something. Okay, Anu, let me go to your slides here. Wait, how do I do that? Yeah, I got it. Okay. Okay, Ananya, remind me a bit, which part of the slide are we in back then?
We're at gamma decay. It's slide 41.
Gamma decay. Okay, wait. So I have an error. Let me reopen. I know the numbers might be quite big, right? Can you? Oh. Okay. At this point, you may want to use calculator to help you a bit. Anu, do you know how to do that?
Yeah.
Okay, right. Okay, don't be intimidated by the number. So 41, right? Okay, 40. Okay, 41, gamma decay. All right, so Ananya, back then, gamma decay, I explained to you, is a super X-ray, right? When we say super X-ray, it means that it will go through a lot of things. That's what being super means. Okay, but other than that, nothing special. Gamma ray has no charge. It's not even a particle. It's just light, super light, super X-ray. X-ray is light. Is this acceptable conceptually?
Yeah, I think so.
Are you intimidated by the phrase very high energy photon bracket EM waves?
No, I think it's okay.
The phrase below, they are emitted when a nucleus decay from a blah, 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 blah. Is that phrase talking about something new, or is it something that you know already?
Something we did before.
Yep, there is nothing new with this. You're correct. Yeah, it's just that we have a very super high energy light currently. That's all. Okay. The next slide is a good information. It's a good information, but nothing special right now. Look at the slide conservation of nucleon number. Is this something new, or is this something that you already know? Wonderful. All right. So Anu, you will know that you will reject -11, right? And then your answer will be 12, no? Right? Are you ready to check the answer? Okay. Joshua, are you okay? You do need rulers and protectors, so you can do it with them later. You cannot just sketch, yeah? It has to be a very accurate drawing.
Oh, okay.
Right. It is the requirement is an accurate drawing. If not, you won't get much. Okay.
Oh, scale diagram. Okay. Yeah.
Scale diagram is accurate drawing with protector and ruler. Okay, Kyoko, I can see you, yeah? Okay. Kyoko, how are you feeling today?
A bit tired. I went to school today.
Oh, that's fine. Okay. We just take it slow and do homework. You have homework, right?
Yeah.
Right. Let's just take it slow and,
Okay.
and do what we can first today. Yeah.
Okay.
Because when I shared with you the schedule last time, I was proposing to you we're not supposed to be anxious. So okay, we take it slow for now, right? Take it slow.
Okay.
Is there anything wrong, Anu? Yeah?
I think it basically means the same thing, but the answer key is a bit different.
However, the answer is 12, right?
Yeah.
Then you're fine. Then you're
Yeah. Yeah.
Really? How do you feel? Isn't it a good job for today?
Yeah.
Not bad, huh? Okay, good job. I'll see you next week. Okay, right. So Joshua, if you're too tired, you tell me, yeah? Okay. So Ananya, slide 40, I'm so sorry, this is slide 44. Hey, I'm sorry, slide 43. Okay or not okay?
Yeah, I think so. Okay.
Yeah, I hope it doesn't look confusing because we're just saying that, the number on the left must be equal to the number on the right. That's all we're saying, right? Okay, which is you already know. And then we are at half-life, radioactive decay, random, spontaneous, other stuff. Do you want me to explain?
A bit.
Okay. You have never encountered a process which is random and spontaneous. Never. Let me explain what it is. That means it's a bit difficult to rely on our intuition, but I can describe what it means, right? This is what random means. It's gonna feel very weird, actually. Yeah, it's gonna feel very weird. If I describe it in real life, it is very weird. Apologies if this feels spooky. Yeah, right. Okay, so what's your favorite snack, Ananya? Snack. If you have a favorite snack, if you have.
Anything.
I'm sorry, what is it?
Anything works.
Anything works? Something salty or something sweet?
Salty.
Salty. Okay, I don't know, potato chips. Okay, right, potato chips. Right, let's say you like potato chips and you're eating potato chips, and then these potato chips, one of them, you put it on a plate so you can eat easily, right? Okay, and then one of the potato chips will spontaneously change. Spontaneously means without any reason whatsoever, it change. For example, it can break into two, or for example, it will fly, or for example, it will do things that will seem extremely weird because there is no reason for a particular potato chip to fly around, or to crack, or to break into two, or to disappear, or to spin. The worst thing is, after a while, another potato chip will do that. After a while, another potato chip will do that. That is what it means to be spontaneous. There is no reason that happens. To us, it's spooky because that's not how things are supposed to be. We are spooked by it. There must be a reason why this potato chip is flying around. Maybe my brother is pranking me. Maybe it's a bit old already, right? Maybe this, maybe that. Maybe there's a wind, right? But that doesn't work. That logic doesn't work at all for nuclear decay. It just happened. That's it, right? The flip side of it is that it is not influenced by anything also. You cannot make it faster, you cannot make it slower. You cannot raise the temperature to make it higher. You cannot make it colder and make it slow down. It will happen at its own time, at its own pace, and nothing can stop it, influence it, or make it faster or whatever. That's what spontaneous means. Will this be okay?
Yeah.
As for random, it simply means that at this context, it simply means that you cannot predict which one will undergo change. There's 20 Pringles, and there is no way to predict. It will be one or another, but it will definitely happen. That's what random means. You cannot predict which one, but you can predict it will happen.
Okay.
Which is, again, it is not something that we see happen in our daily life. We don't like random stuff. It's very jarring, and even worse, we don't like spontaneous stuff. We don't, right? Okay, that's the meaning of the words here. Okay, but this is a nuclear stuff, so okay, we won't be seeing it in our daily life. Okay, that's it lah, right? As for the formalities, the scientific words, it is good to memorize. When it's time to apply in exam, let's see whether the meaning I gave you is helpful or not, right?
Okay.
Okay, so, oh, Ainesh, okay. Ainesh, I can see you. Can you hear me?
Yeah.
Okay, so again, do turn on your video and you have your stock of question. Let me follow you. Okay, let me follow you. Yeah. Okay, so Ananya, the next graph is one of the most important graph lah for the decay process. If you understand it, then good. If you don't, it is important to take time. Are you okay or not?
Yeah, I think so.
All right. Okay, then I take it that the example question you can do lah.
Oh, the half-life one.
Yeah, that's the one of the application of the graph. Can you or can you not? If you cannot, don't read the answer key. Don't.
I can. I've done this in school. So
I'm sorry, I can't hear you. You're saying?
do it. Yeah.
You okay? Yeah, you can do it. Yeah. Okay, then that's fine. Okay. Good. Okay, and then measuring radioactive decay. I mean, okay lah. I mean, it's not the most important slide. Can I skip it?
Yeah. Okay.
Background radiation is important conceptually. Do you understand what background radiation means? Joshua, are you okay?
Hmm.
Do you, this is just an offer. Do you want to stop for now?
Sorry.
Do you want to stop for now? I mean, if you're tired,
I think I'm okay.
go.
This one. This a bit. I'm a bit stuck on explaining this one. Like I know the basic theory. Like
Oh dear,
um,
okay.
yeah,
So
like
give me an idea why acceleration decreases. Just your idea.
okay, hold on, because I play like driving games and I watch F1. So like when it goes top speed, right? I don't know. It reaches the engine's capacity, I guess. To I don't know. Accelerate even more. I don't know. That's my basic
No,
knowledge. I know. Yeah.
right. To your surprise, this is a very standard answer. Don't see it as standard. I think you don't understand it, and it is already hinted, like even in your answer, air resistance. So
Oh, it's
it just says
resistance.
air resistance increases as the speed goes up.
Oh, that's it?
Because acceleration means you make the speed go upward.
Yeah.
If the speed goes up because of your current acceleration,
Mm.
then the friction also goes up, which in turn reduces the available acceleration.
Okay.
Right? That is what has been happening now. So he's just aiming towards that.
Yeah.
So to speak,
Okay.
standard thing. Now
All right.
you try to put your answer and then like that. Okay. So Ananya, are you okay with the slide background radiation?
Yeah.
Sure. So for example, this is an example to test you. I have to measure a certain radiation when I'm in a danger zone. So easy, I just take the Geiger-Müller thingy, right? And you will see when I'm close to a radiation. Then the counter tells me, okay, there's there's 50 counts. There's 50 counts of radiation when I'm near a very radioactive source. Okay, 50 counts. So I run away from the radioactive source because it is dangerous for me to be nearby, right? So I run away very far. Do you expect my counter, the radioactive counter, to drop to 0 from 50? What do you expect?
A smaller number?
Why is it not 0?
Because of background radiation.
Wonderful. That's it.
Okay.
You cannot run away from background radiation. It's just constant everywhere, so to speak. Right? Okay, that's it. Okay, understand. Okay, so I will not go through the slide one by one. It is obvious that what you're telling me, you understand this one better. Obviously, you get a lot of things right. So why don't you tell me which slide you want to explain? You want more explanation? Is it? What do you think? Okay. What do you think we do it that way?
Yeah, okay, sure.
Okay, sure. I'll be waiting for you. Yeah. Okay. So Ainesh, again, video, please, so I can follow you. Okay, good, Ainesh. I can see it. Yeah, I can see it. So Ainesh, which one do you decide to do now? The binomial is a little bit difficult. You can try lah, but I wouldn't object you trying the sets question and the probability question. Those are very good practices lah. You stand
Yeah, I
a
don't mind
chance of
doing them either.
sure thing, right? You decide what you want to do, and I'll follow you. And like other people, ask me questions. Very happy to help.
No circles, right, obviously, since we haven't learned circles.
Oh no. Stay away from circles. Stay away. You'll be able to do it next time. Yeah, not today. Not today. Okay, Kyoko, are you okay? You're not stuck, yeah? Kyoko, okay, yeah? Okay. The question doesn't look very difficult, yeah? Okay, I mean, okay, warm up lah. Let's do warm up, okay? Ananya, are you okay so far?
Yeah, I'm reading the slide.
Sure thing. No rush, yeah? No rush.
Yeah, I'm doing on page 18.
Page 18, wonderful. But do it on paper, lah, right? Do it on paper. It's just easier for you, right? I'll follow you, lah. Page 18 would be, that thing, okay. Please do it on paper, right? Oh, wow, that's, yeah. Oh, that's not very straightforward, lah. I expect you to ask some questions, yeah?
I'm already confused.
Fair enough. Now I invite you to use a paper and then to draw a possible Venn diagram. That's how you start. Draw a possible Venn diagram. And then I'll guide you through. Joshua, are you okay so far? Oh, goodness me.
I'm a bit stuck on the
That's
explanation.
not something that you're supposed to know. What? What? Okay, I'm going to ask you to skip this question first. This requires something beyond the syllabus. You can understand it, but it's not 1 or 2 sentence thingy lah, right? So not your fault.
Is it okay if you can like explain it now? If you're okay with it, because like I'm quite free. Like it'll be like good to have like, you know, outside of the if you're fine.
I'll try the
Perfect.
short one first. If the
Yeah,
short
sure,
one doesn't
sure.
work, then we'll
Yeah.
wait for a while. Then
Yeah, I'm fine. It's okay.
right.
Like, cause there's some free time, so.
Okay. So do you know? Ainesh, draw the Venn diagram. Okay. Do you know that your weight changes depending on where you are on the earth? Joshua, you're muted. Yeah?
Actually, no, I did not know that. I thought it was like,
Uh-oh. Right. Okay. Then let me ask you this. Your weight definitely change if you go to space. Right?
okay.
Oh, you don't. Oh, okay. No, that's it. That's it. Okay. For example, you stand on the moon.
Oh, okay. If you're like, okay, yeah, I know that. Okay,
Okay.
yep,
If you're standing on the moon, your weight changes.
it'll
And
be-
if you
it'll
go
be
to
shift.
space, your weight also changes, right?
yeah, okay, yep.
Which means if you just go a little, let's say you go on the top of the mountain, which is nearer to space, believe it or not, the weight changes. Your weight
Huh.
changes. Even though your mass stays the same. That's always the concept. In the moon, your mass is the same. You don't lose any mass. You're not dieting. You're not dieting freely. No, your mass is the same. Your fat is the same. Your muscle is the same, whatever. But your weight changes because the guy causing the weight is smaller or further. In this case, the moon is smaller. You go up the mountain, you are still on Earth, but you're slightly further from the Earth center. So your weight is ever slightly decreased. Ever slightly. This is the
Oh.
basic of the concept first, and then we go try to explain that's why I'm trying to avoid this. It is out of the syllabus one. It is amazing if you want, but okay, if you don't mind, I'll keep you all the delicious stuff next week or something, if you don't mind. If you don't.
Yeah.
mind.
Okay.
Okay. Try the next approach. So Ainesh, I can see the Venn diagram, but help me zoom in, please. Yeah. Cannot see your drawing very well.
Is the total of the Venn diagram a 1?
Ainesh, just now I asked you to zoom in, right? All right, okay, a bit. Oh no, you're doing no. Well, your logic is working fine. You're good. You're wonderful. The total is 1, including the universe. So,
but what's outside the universe and not inside M&M?
You are absolutely correct. You wouldn't know. To be fair, it is true that you don't know. To be fair. So let's see whether the thing give us, right? Okay. The thing does not give us. Nasty, right? Nasty. No, it's nasty. But your question tells me that you're thinking. Okay, that's a very good thing. So now watch what the question asks. Huh? The question asks you for, M intersect N, not N, right? Now I'm going to use visualization. This is not N. Isn't it correct? That's not N.
Yeah. This is not
Okay. And then where is M? So where is M? So intersect M, right? So just to be clear, M is here. I mean, just to be clear, that's M.
Mm-hmm.
So what is M intersect not N? Where is it?
So it's 0.44.
You are a very wonderful person.
Okay.
But with the help of drawing, and that's why I keep asking you draw. It'll serve you well.
Mm.
Okay. So try B, even worse, but try. Ananya, are you okay?
Can you explain slide 58?
58, wonderful. 58, sorry. Yeah. Okay, now I got it. 58. Okay. Wait, sorry, why so slow? Yes, unified atomic mass. Okay. Okay. Blah, 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 reference. Okay. The point is this. AMU, sorry, here it says a U, okay? Either AMU or U, okay. A U is very useful thing for the same reason as EV. Remember, EV is, much smaller than Joule. Then I was introducing to you because we needed and everything, right?
Yeah.
U or AMU, U is a very small version of kg, right? The important thing is not even the number here. The number here, I believe they will give in the data booklet. You're not supposed to memorize this. The point is very simple. Like EV gives you a nicer number to work with in the in the nuclear size, which is very small. That's what U is for also. The point of U is not to ask you to memorize this field number. The point is U is going to make your life easier, even though you can't see it right now. You probably cannot imagine how it makes your life easier, but it is going to make your life easier because it is designed to work with things very small, and it is designed quite well, I must say. Same thing as EV. So let not the weird number confuse you. I hope to show you how it is useful in a question. Okay? Will that be okay? That will be my explanation. Is that okay?
Yeah.
All right. Okay. Please ask me more. Yeah. Kyoko, are you stuck? Sorry. Are you stuck with finding questions?
Yeah.
Why is it? Because everything is easy?
No, I don't know how to do the. Still thinking.
Show me lah. Then show me. Let me give you something. Right? So Ainesh, are you stuck with B?
Yeah.
Okay. Now I'm asking you to draw, or more precisely to shade. Okay. So first of all, I'm asking you to draw another Venn diagram, which is the same thing. No need the number. Please do that.
Wait, what is this?
Below. Let me explain. Come, draw first. Draw another one quickly. right? This is just the exact same thing as the one on top, right? So you must understand that this N looking thing is intersect, and this U looking thing is union or unite. Now, unite is a very simple thing to understand. M unite with N, correct? Okay. M unite with N is as simple as this lah. That's M unite with N, correct?
Okay.
Then he is asking you to actually shade M unite with N, not
outside
M
the universe.
Which tells you what you need. No, it's not outside the universe. No. It is the universe. It is the remaining of the universe.
Oh, yeah.
So that's what you need, right? That's what you need to complete your Venn diagram. Go ahead.
But what does this mean?
It means that the outer guy is 0. Oh, goodness me. Oh, that's so difficult to see. Okay, let me explain. Write down the 0.19 first and work out the rest first. And I'll explain to you what it is.
Sure.
Joshua, are you okay?
I forgot how to do the. I don't know how to do the free body diagram part of the diving board.
Okay.
I don't know if this is like tension or something. What should I call that one?
Yeah. So most probably the spring is keeping the board from going down, right?
Yeah.
Which means the spring is pulling the board in direction. I totally agree with you. I have one more question regarding your FPD. Your FPD should include, the weight of the board. The board has weight, no?
It says it's above P, so around here, which is the pivot itself.
Oh, that's very nice. So still draw the weight, Still draw the weight.
I'll draw the weight. Okay.
And lastly, the pivot will exert a force upward to the board, if that makes sense, because it's supporting the board.
What do you call that force?
A normal or reaction force. I mean, the point is a supporting force. It's just a supporting force. And then this is okay. Now, if you take the pivot at P, you will eliminate a lot of trouble. Right? Hey, Ainesh, combine it with the original thing, 0.19, and then work out the rest. Oh, which you did, right? Wonderful. Okay, that's a very nice number. Okay, wonderful. Now, let me tell you what it means. Okay, Ananya, are you okay so far?
Can you also explain slide 61?
Yes. Ainesh, don't wait for me first. The explanation will take some time. Please do the next question first. Okay, Ainesh? Hold your attention for a while. Don't let up your momentum. So slide 61, Ananya. Oh, goodness me. Right. Okay. This is the most important concept. Joshua, since time is up, I'll see you next time. Okay. Right. Okay. Good job for today. Yeah. Really. Good job for today. Really, yeah.
Thank you.
So Ananya, okay. So I'll explain mass defect by what it means. Do you know that we are now talking about mass can convert to energy? Energy can convert to mass. Do you know that?
Yeah.
Okay. Mass defect is therefore very simple. The description is not the most helpful thing. It's not. Mass defect means I lost some mass. First thing first. I can gain some mass, but the meaning is very simple. If I lost some mass, I must have created energy from that loss of mass. I have basically converted mass to energy. If mass defect turns out to be actually I'm gaining some mass, that is possible. That happens. So if I gain some mass, I must have absorbed some energy and converted to mass. So either mass becomes energy or energy becomes mass. That's the context first. Does this make some sense?
Yeah.
Now the example. The example is like this. The example is I have one free proton and I have one free neutron. If I weigh them separately, it's very weird. They weigh this U and they weigh that U. And then when the proton and neutron actually combine, they're not free. They combines to be a deuteron, whatever deuteron means. Yeah? Okay. When I weigh the deuteron, it weighs slightly less than if the proton and the neutron are just freely existing. This is experimental. It's not something that we expect to happen. Hey, proton and neutron stick together, the mass should be the same one. What are you talking about? experimentally, it's very weird. The mass of the combined proton and neutron actually decrease. This is something that you must have faith in a little bit like you. We don't experience it in real life. But it is, however, verified experimentally. Again, asking you to trust it a little bit. Okay, that's the first part of the story. Is it okay so far?
Yeah.
So there is a mass loss. Hey, what's going on here? But we know what's going on. The mass loss, the diet, the loss of mass is not that another mass is ejected. No, that's not what's happening. It is simply energy is ejected. So when a free proton and a free neutron actually combine and decide to stay together, they eject some energy. The proof is they lost some mass.
Okay.
That loss of energy, they call it binding energy, means something very important. Think about this for a while. If you lose some energy, you're more stable or you're less stable.
Less.
Think about it for a time. If you have a lot of energy, you are more reactive or less reactive.
Oh yeah.
Okay, so if you're more reactive, you let out some energy, like you let out some steam, like you just give away some energy and you become calmer and more stable. Correct? That's the same thing with this particular stuff. So I let off some energy. I'm more stable or I'm less stable?
More stable.
So by that logic, that human logic, proton and neutron separately or proton and neutron combined, which one's more stable?
Separately.
No, combined, because the combination implies that you lost some energy. Why? Because the mass is small.
Oh, okay.
Okay, whatever that, however we word it, that is what binding energy is trying to address. Binding energy is saying that, oh, you lose this amount of energy. Oh, you must be this stable. The more you lost, the more stable you are, if that makes some sense.
Okay.
Okay. And that is enough for this slide because the rest is application in question. Okay.
So E equals to mc square, E is the energy.
The energy converted from the loss of mass, or the energy needed if the mass is gained, whichever lah, same thing lah.
And m is the mass.
Mass is, and c square is the speed of light, which what Einstein discovered lah. So credits to Einstein.
Okay.
Okay, nothing stops you from asking slide 62. Yeah? So Ainesh, are you okay with the next question so far?
Yeah, I finished one part already.
Wonderful, wonderful. Moving on, yeah, gain more confidence, gain more confidence. We'll come back to that question. Yeah, Kyoko, are you currently stuck? You are not adding any. Oh, you did add some questions. Right. So, do you want me to explain this?
I'm still thinking.
What do you want? Let you think. Let me help a bit. What do you want?
Have a beer.
Okay, a little bit, yeah. This is not very this is not very easy. Okay, it's not very easy. Okay, I rarely see a question this difficult for a supposedly e-math question. Correct? This is supposedly an e-math question because this part is always e-math. Correct? Yeah. Never seen something. Okay. Now e-math lah. Back to e-math. What is the volume of a cone?
1/3 pi r.
Yeah, pi r squared, which is the base lah, right?
Yeah.
And then times the height lah, correct?
Yeah.
Which is not the h, which makes it more confusing. So I have to make it big H. Okay, so now you need to know this guy, right? What is this guy? And you also need to know this guy, what is this guy? Correct or not? Okay, now do you notice what this means? Unit radius?
No.
Unit radius means the radius equals to 1 unit. I think that's your problem. So what is this? What is that? I'm going to give this as y. I'm going to give this xx. So if the radius of the sphere is 1, what is y and what is x? Go and find it. Okay, that would be the most help I should give you. Ainesh, are you okay? You seem stuck.
Yeah, I was trying to figure out the dash thing.
Right. It will be much better if you just write down the member and not think too much about it. Write down the member first. That's the lesson you learn from the practice paper, from the, your school paper lah. Write down the members.
Members.
Yeah, the universe has a very limited members. Write it down.
Mm.
Write it down. Stop thinking in your head. Write down and then think. Right? Universe. The member of the universe is la 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 la, and then continue lah. Hey, why are you stopping?
You know, I'm talking about 3B.
I know. 3B. No. Do 4B first. Do 4B first.
Oh, okay.
Do 4B first. It's easier. You can do 4B. Do 4B. Go. Get more confidence. Ananya, are you okay?
I have a question about slide 65.
Yes, please. Which is a practice question. What is your question?
They calculated the mass effect, then they did 20 multiplied by the mass of the neutron and the proton.
Yeah.
Why is it only multiplied by 20? Why not 40?
Oh. It's 20 neutron and 20 proton. What? Correct? That's where the 40 is. 20 proton and 20 neutron. Would that make sense?
Okay.
All right. Okay. And then you minus the combined mass, which is supposed to be smaller, and then you find the loss of mass. You convert it to energy. That's the energy what you lost. Yada.
Yeah, that part is okay.
Okay. Don't worry. It's a simple mistake, right? Hey, how come I missed that? But that's because it is disorienting one. It's disorienting to think about all this because it's not natural. Take your time. Okay, be slow and work it out, right? Okay, good. Kyoko, that's one lah. You're okay with that, right? Now, is there any EMAT technique to find X? And I really mean EMAT technique, no fancy techniques, just EMAT. Is there any way using EMAT technique to find X?
No, volume.
Yeah, actually, I also wonder, is there any particular technique to use that? Yes, there is. So at this point, I choose to reveal to you the secret. And I hope that you will remember it in case you need it next time. Okay? This is also one. Correct? It's not that much of a secret, but that's needed. Isn't that also one? Are you okay? And are you okay?
Oh, okay.
And why is that important?
Pythagoras.
No, wait, yeah, Pythagoras. To find the x, no? Like because we want the x, no? Turns out that the one matters a lot for the height and for the x. Correct or not? Give it a try, get your 3 marks, and then move on to other difficult ones.
Okay.
Ainesh, are you stuck?
Yeah.
Where's your member for 3? I don't see any working. What's going on here? What are you thinking from your mind? Why are you not writing stuff? What do you make your life difficult? Show me your members. I cannot see. Sometimes I have to beg you to do certain things, right? Okay. That's not a praise.
Where was this?
What is what?
That symbol.
Which symbol?
I just circled it.
A set. Okay, so that doesn't help a lot. Sorry, that doesn't help. Okay, let me confirm.
So
by
what do they mean by this?
Okay. 4, number 4 lah, is a member of intersection A and B.
Okay.
Okay. He's telling you something important lah. I mean, it is I think important to put that in the Venn diagram. Would you please do that by drawing in your paper, please? Anesh, do I have to beg you to draw again?
done. Okay, I've done it.
Okay, show me your working by moving to the left. Okay. Kyoko, apply the, yeah, okay, apply that, please, and then work it out lah, work it out. Ananya, are you okay?
One question.
I'm sorry, which slide, sorry, your question?
Okay, 67.
67. Oh, slide 67. Sorry. Okay, yes. What is your question?
What is A? Is it like the number of nucleons?
Yes, because that's the symbol, you know, Z and A. You do, oh, you don't do chem, so what am I talking about? Yeah, the A is the nucleon number,
Okay.
like 40. Yeah, good question. Right, good to
The
clarify.
slide on top of that, like slide 66.
66, which is already per nucleon. That number of nucleon A lah.
Yeah, but
Okay.
the bottom says the higher the binding energy, the more stable the nuclear.
No, the higher binding energy per nucleon,
Oh, okay.
not the higher the bind. Wrong. Per nucleon. That means you lost more energy, right? Because binding energy means the energy you lost, right? Remember?
Yeah.
You lost. You cannot just say that I lost 50 joule, for example. Is it 50 joule spread across 3 or 50 joule spread across 2, for example?
Mm.
If my 50 joule is spread across 2 and compared to spread across 3, which one is more stable?
3.
No, 2.
Yeah, sorry. 2.
Because each lost 25. If spread across 3, each lost, I think, 17 something. Kind of gives you an idea. Yeah, lah. Both of us lost 25. We're bound more, we're more stable. Each nucleon is just more stable. Kind of something like that. That's the meaning.
Yeah.
Right. And then they tabulate this, and then they found, like, you know, there's certain things which are very stable, including the Fe. The iron is very stable, so to speak lah. Right. Okay. Kyoko, are you okay so far?
I don't know how to work it out.
Let's check for a while. Okay. Look, it's pi r squared times h, right? Tell me who is the r? R squared, right? R is r squared, right? So the square root disappear, right?
Oh,
Correct or not?
mm.
Okay. You're a bit messy, so you know you're a bit messy. So the square root disappear with the square, and then what is the h? What is the height? What is the height?
Which height?
What are you talking about? The height of the cone. What is the height of the cone?
Oh, yeah. I haven't found that.
But what is it? I mean, look at the drawing. What is it?
1 plus h.
Okay, so do the formula properly, yeah? Do the formula properly, yeah? The square root is cancelled by square, and then the height is also simple. Do it properly, yeah? Okay. Ainesh, you're stopping. What does this mean? Oh, you draw that. Okay, fine. Oh, you did complete the diagram. Wonderful. Right, so you have all the answers for 4B, right, Ainesh? Are you confident to check the answer key?
Yeah.
All right, so please do, and then we'll move to the previous question.
Do you have any idea which paper this is from?
Either 2019 or 2020, either one.
Okay.
Ananya, are you okay?
Yeah, I'm reading the slides.
Sure thing, no rush. Wonderful, Kyoko. Wonderful. All right. That seems to settle it, like Kyoko, yeah? Okay. You must be a bit tired. I mean, the tiredness is affecting you. Should you do difficult question? But yeah, I mean, what else, right? It's okay. Let's go slow, but let's do something that you don't think you can do, lah, right? Okay, that will be helpful, right? This is homework, right? Okay, yeah, it's okay, lah. It's okay. I'll accompany you to do things which are difficult, lah. Now, as for the maximum and minimum, if you are quite okay, I know you're tired, but if you're quite okay, the feeling is okay, maybe you can skip it, lah.
Okay.
As for part 3, I suggest that you skip it part 3 first because it will be difficult to understand since we are tired. When you're fresh, I think it's better to come back to part 3. Would that be okay? Right. Freshness is important when we're dealing with the hardest part of the question. I feel that this one, don't force it. I feel. Okay. The previous one, I feel is easy enough. So the tiredness is definitely taking a toll because it's not the most difficult question and you kind of get a bit wonky. That means you are a bit tired. Again, let's skip part 3. Okay. Let's do maybe another challenging question. So Ainesh, how is it?
It's not a 2019 paper.
Okay, then go and find it. Right?
Yeah, I'm still looking to change it.
Ananya, how is it?
I think the nuclear fusion and fission is okay.
Right, that's important. Yeah. Okay.
I'm at slide 85.
Let me go. Go slide 85. Okay. Oh goodness me. It's gonna be even worse. This one doesn't even have any bearing to our normal experience. Okay, you are fresh enough, yes? If you're not fresh, we'll skip this part first and we will need to come back now. Okay? You okay, yeah? All right, okay, let's try. None of this will make a lot of sense, but I'm trying my best to make it sensible because it is also very weird for the guys who figure it out first.
Okay.
One more time, this new guys are quarks, leptons, blah, 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 do follow a certain rule, which is how we know they are part of the creation, the design, or the work with it. Whatever you believe, this thing is ruled by, I mean, we have rules like gravity is a rule that everybody must obey. Our atoms follow a certain rule, and they are very stable rule. If not, we will cease to exist. Okay, right? So the guys that made up proton and neutron, quarks, and all those stuff that you will learn later also follow a certain rule. The rules are the important here, even though they don't make sense, the rule is followed. We are learning that rule, kind of, and then we can kind of predict how they will behave. That has been the purpose of every chapter, including this one. What's the rule here? What's the rule here? It's just that this time it's gonna make very little common sense, but there will be rules. Okay, I apologize first. Okay. Okay. The names also doesn't make a lot of sense at all, really at all. Okay, so I'm gonna go to somewhere which is which is a good start. Okay, it's not that slide. I'm gonna start at
Yeah, it's correct.
Wonderful, Ainesh. How do you feel?
Good.
Good. Okay, so Ananya, I'm going to ask you to go to slide 93. We'll start from there. Do read it first, okay? Do read that first. Yeah. Now, Ainesh, the M dash N prime, okay? This thing, okay? Okay, my promise to explain to you. This is not difficult at all if you see your drawing lah. So please look at your drawing for now. Yeah, this is read as M if n prime. The dash here is read if. You okay?
Okay.
Okay, what does if mean? It's so simple. The if means you just shrunk the universe into n prime. The universe is originally the big box that accomplishes anything, right? Encompasses everything. Now, the word if shrinks that universe into only n prime. Are you following me?
Wait, only what?
Only n prime because
N prime.
if n prime and not whatever n is n not or n prime. This guy is the new universe. We shrunk the universe. Let me repeat. We shrunk the universe. There's a meaning to it. I don't have time to explain today lah. But we shrunk the universe is the important thing. Now let me show you visually what it means. Okay, using a fresh Venn diagram.
So do we calculate n proportionally?
Because of the shrinking, yeah, but we shrink it first. So remember, what is n? What is n naught? The n naught is just like this. So our universe has just shrunk to n naught, which is
This.
Maybe this is the easiest way to do it, right? So what I cancel, I'm canceling the red one because it's n, right? The remaining is n naught, correct? I'm canceling the red part, correct or not? The remaining part is n naught, not n, correct? This is our new universe. This is our universe. In effect, using numbers is easier. I cancel the 0.18, I cancel the 0.19. Simple, right? It is no longer in this universe, in this new universe. What is left is 0.44 and 0.19 outside. Am I making any sense right now? Because my new universe is n naught, whatever is not n. Am I making some sense, Ainesh?
No. So you're telling me that n is removed from the universe?
Yeah, that's what it means by if. If n not, n is removed. The new universe no longer have n. That is what it means.
0.44.
It still has 0.44 and it still has the 0.19 outside. Correct?
So the answer is 0.44 then?
No. The answer is the new proportion 0.44 over 0.44 plus 0.19, because you know what? This guy is the new universe, this whole thing.
Oh.
And that's the answer, and that's it. That's it. Now you can check the answer key after this. Okay. Are you okay, Ananya, with the slide 85? Hey, 93, sorry.
Yeah, I kind of get it. So there's 6 different types of forms.
Yep. And oh, he has it. Oh. Okay, so I thought, yeah, you are correct. The most famous one is up, down, and later strange. Okay, up, down, and strange. Right? Why is that so? It happens a lot in, for example, where is it? Where example? For example, in slide 95, I'm jumping to 95. It's not a very nice looking slide, isn't it?
Yeah.
Please memorize, for whatever reason, proton is UUD. You have to believe that for now. Proton is UUD. And neutron is UDD. You memorize that first, you'll get more bearing. Okay. And that means that, first of all, my proton baryon number is 1, which is the requirement. A baryon number must be, must be an integer lah. Must be an integer. So 1, no? And no, that's all. I'm saying that's the charge number. The charge number is 1 plus neutron will make it 0, which is what we expect. Charge 0 and charge 1. And then there's also the baryon number, which you should, the next slide we'll talk about it. So UUD will have a charge of 1, which is the total of the individual quarks. Neutron will also have a charge, which is total individual quarks. So this is starting to make some bit of sense.
Yeah.
Right. The slide below is the conversion of baryon number, but the point is a normal particle that we know, for example, proton, is going to be a whole number, which is 1, or in this case, a -1 for a antiproton. Oh, the slide is fully messed up. This is not helpful. The slide is messed up. The slide is messed up. Okay, so I'm going to write something on your Jamboard. Okay, the slide is messed up. Ainesh, how is it?
I'm trying to find the answer. It's not in 2020 at least.
Right. But I hope it is going to be worth it. Right. So, Ananya, I'm trying to fix the slide by going to the Jamboard, and then you got to fix your own slide. Yeah. Okay. The slide, the slide is, I'm sorry, it looks like the slide is messed up in my side. Is the slide messed up in your side?
Yeah, I think because I downloaded as PDF, so some of the words got shifted.
Okay, so for now, I'll just fix the important thing, right? I'll just fix the important thing. Please look at the Jamboard from our trial at page 4, right?
Oh, there's no answer.
How is it?
There's no answer for this.
Huh?
For 2019, apparently there's no answer.
That's so annoying.
Yeah.
That's anticlimactic, right? Okay, so yeah, okay. So what to do?
I'll
Okay.
choose another question.
What you do is to move on, but I can tell you that you're getting a lot of good things. Now, so Ananya, I did ask you to memorize proton as UUD and neutron as UDD, right? Now, what is messed up is the antiproton in the next slide. Antiproton should be written like this: anti-U, anti-up, anti-up, anti-down. Follow some logic. Right? Antiproton is composed of anti-U, anti-U, anti-D. So the slide is kind of messed up that way.
Yeah.
Okay, so would you please fix that?
Okay, I'll take it down myself.
Yeah. Okay. When you're done, please tell me. Yeah.
Yeah, okay, can.
Okay. So there is a reason why they talk to you about baryon number, because baryon number is conserved. Conservation is going to be a very important thing. In whatever reaction you write, the baryon number on the left before and on the right after will always be total the same. That's what it means to be conserved. So it's a big deal. It is a big deal. Charge is also conserved. It is a big deal. Why is this even more big deal? Because the mass is no longer conserved. Remember, mass can change to energy, energy can change to mass. So mass is no longer conserved. Rather big deal. Baryon number and charge is going to be conserved. So it is important to know the individual baryon number and individual charge so that we can work out the conservation. Am I making any sense?
Yeah.
So we start with the memorization of proton and neutron because you don't have to memorize antiproton, right? It's just anti-U, anti-U, anti-D, right? Okay. I am going to so look at the slide 97. This is an example of something that you don't have to memorize. Slide 97. Okay. So he say lambda 0 particle. What the heck is that, right? What the heck is that? It's a baryon having the quark combo UDS. Okay. You don't have to memorize this. UDS. Okay. You just have to work out. Okay, what is its charge and what is this strangeness? Now, you have to work it out based on what you know about U, D, and S. So look at the solution, look at the table. It's a simple math. Can you use the table to answer this question? If you cannot, we'll talk about it.
Table at the start.
Which table? Okay, right. The table is the table that, okay, let me find the table, right? Let me find the table. Oh, there you go. The table in page 91.
Page 91.
91, right? I'll just put it in the Jamboard. Okay, so by using this table, you can work things out quite easily. It's just simple math. So give it a try. Okay, Kyoko, are you stuck?
Mm.
Okay, so I'm gonna make it bigger. Yeah, sorry, yeah, it's difficult for me. Uh-oh, I think you're a little bit tired, lah, yeah. Okay, so for minimum value, it's true that you find dy dx, right? So what do you do with the dy dx? For a minimum value, Kyoko? Okay, slow down and think. For a minimum value, the dy dx, you do something to it. Dy dx. Okay, I'm gonna draw a minimum value to you. I'm gonna the gradient. What is the gradient of a minimum value?
0.
And what does that have to do with the dy dx?
0.
And will that help you a little bit?
Um,
Okay, that's one thing to use. Your A is this is all wrong, yeah? Okay, yeah. I think you're just tired. Okay, so you do this, right? And then this is x equals to 2.5 and y, I'm sorry, that's y I'm talking about. That's y equals to 2.5, x equals to 1.5. What do you do with this?
so in the function.
Original one. Yeah.
Yeah.
So, and then you do that, you find a and b, right?
Okay.
This is nothing new, and that's why I think you're tired.
Okay.
Okay. Would you be better if you just stop right now and we'll see you tomorrow? Will tomorrow you'll be as tired as today?
No.
Okay. Do this and stop it, and I'll see you tomorrow. Okay.
Okay.
You are too tired. It's very weird, yeah. In holiday, you're more tired than usual. Right. Okay. Ainesh, how is it? What is the next
Hello.
question that you're doing? I'm not seeing anything here.
Oh, I'm doing question 7 on page 17.
Question 7 on page 17. Oh, that's so small. Okay.
How do I move this in front?
I'll just duplicate it. Okay, now I've duplicated it. Now, could you please delete the other question?
No, I moved it already.
Okay, wonderful. Okay, now do you know how to do this? This is, if you just know, it's going to be easy lah. Okay, so Ananya, can you work out that particular slide? I think slide 97, right?
Yeah, I don't understand the hashtag anti-strange thoughts on this. Strange thoughts. But the
Wait.
chart makes sense.
Wait. I'm also a bit confused. What's going on here? Wait.
Okay.
What? Wait, what's going? Wait, what? What's going on here? Wait, I owe you this question. Yeah, I'll answer it either now or after the tuition. Yeah, I owe you this one. That looks very confusing to me, right? Yeah, I owe you this question. Right? Okay. From now on, let's move on first. And he suddenly jumped to this. Let me think carefully. Okay. No, that's fine. That's fine. Oh. Okay. Oh dear. Okay, right. So question 98 is a reaction. Okay. You're gonna ignore the title conservation of strangeness for now, right? You're gonna ignore that for now because remember, conservation is a big deal, right? Looking at that reaction, it's almost like too confusing, except for the fact that they tell you what's K minus K plus and K naught. They do tell you. Remember, understand? Huh? You don't have to memorize. You don't have to know.
Yeah.
They just tell you the structure. That is enough to work out what is big X. Because why? Because in P, you know P is UUD. Ma?
Oh, yeah. Okay.
By using all this, remember baryon is conserved and charge is conserved. Just using those two conservations, you can roughly work out what is X already.
Yeah.
Okay, now let's try that. No matter how confusing this is, it's not too complicated. It's just disorienting. Okay, give it a try and we'll do it together if you cannot. So how is it? Ainesh? Ainesh?
I lost my box and whisker plot worksheet, which had all the intercausal stuff. And I remember you used to know what this means, but
this is not very helpful, right? This is
I had
just
the online copy though.
This is just self-sabotage or upon self-sabotage, right? Like this is just go and get it the online version. Like repair your own sabotage. Go get the online version. Get it. Get it. When things matter, sabotages happen. Ananya, are you okay so far?
I need to find X, right?
Yeah. First of all, based on the conservation of baryon and conservation of charge, we start from there.
Okay, so if it says like S, U, like K minus is S, then
the baryon number is that's S anti-U, anti-U lah, right? S anti-U. So the baryon number of K minus is 0 lo. Does this make any sense? I first note that lah. All baryon number 0.
no, why is it 0?
Uh-oh, okay, right. So let me see whether the table is enough, right? Yes, the table is enough. Look, so the baryon number of U is 1/3 lah, correct?
Oh, the barrier number. Oh, okay, sorry. I was looking
Right.
at that.
Yeah, which is totally disorienting, correct? But baryon number U is 1/3. Baryon number of anti-S is minus 1/3. Okay, so the total baryon number is 0. Okay, nice.
So it's like addition, right? It's not multiplication.
Oh, addition. Yeah, it's not. Just add them up. Right. So I'll start from there lah. Baryon 0 and then proton baryon 1, right? Something like that.
Yeah,
Okay. And then work out to the right hand side, right? So Ainesh, have you found the digital version? Yeah, yes, Kyoko. Yes, Kyoko, I understand. Congratulations, you can still do it lah. Okay, I'll see you tomorrow. Better, yeah.
Okay. Bye
Take
bye.
care. Bye-bye.
Thank you.
Ainesh, have you found the digital version?
I found the folder where it should be. Now I need to go through the files. There's 5 files.
Okay, go man, go. Fix your self-sabotage. Fix it quickly as possible, right? So Ananya, the baryon number of X should be
1.
correct. So that's a start. The charge of X is, again, you work it out slowly. The table is enough. Table is enough.
So addition.
Yeah. So just add this, add that, add this, and then you'll figure out something, right? Ainesh, have you found the digital version?
Okay, I found it.
Okay, is it helpful with interquartiles? Go and flip it and find it. Come on, and this self-sabotage, and it.
Is the charge for X negative 1?
Okay, let's see, huh? Wait, so I keep losing. Okay, there you go. Right. So just to confirm, the charge of K minus is
Charge of K minus is -1.
correct. It's almost, it's also hinted in the name. K minus actually means -1. Nice, right? So the proton charge is
The proton charge is 1.
+1, correct. So total left 0. Yeah, total left 0 lah. The charge of K0, 0 lo. The charge of K plus, +1 lo. Therefore, for total of 0, X must be -1. Simple math. Make sense? Okay. So conservation of baryon apply, conservation of charge apply. X will be baryon number 1, which means it will be composed of 3 quarks. It's always like that one. Only baryon number 1 or 0. 0 will be 2 quarks. What you see here, K minus, K plus, K0. And baryon number 1 will be the 3 quark version. Always like that. Kind of gives us a lot of like hints already. And then the charge will be -1. Okay, not enough to tell us what, but definitely a lot of hints. Are we okay? Okay, yeah. Okay, so you're already correct so far. Okay, as you notice, the question will be answered in B lah. No, that's a proton. Proton. And then the C. The C. Oh my goodness, he even tells you what is X. What? Why do they tell you that? I'm very confused. Never mind. Okay, so they tell you that X is SSS, right? Actually, I don't think there's a particle like that. What's going on here? Never mind, never mind. You just confirm lah. Is SSS baryon number 1 and is SSS charge -1?
Yeah, it is.
Okay, then for now, we are not trying to figure out X. I'm very confused right now. They tell you what's X. Okay, look. Okay, right. So the whole point of the slide is that never mind. Okay, the strangeness is not supposed to be conserved. What are they talking about? What does this? Never mind. I thought this slide will be useful. It is kind of useful, right? At this point. Sorry. Sorry.
Can X be an antiproton?
I'm sorry, you're saying?
Can X be an antiproton also?
Can it be an antiproton? So let's check lah. Can it be anti-U, anti-D, right?
Yeah,
Check it out. Can it be so?
I think so.
Baryon number is 1 and charge is minus
Yeah.
-1, right? The only thing that is not conserved is the S number, the strangeness number lah, right? And the strangeness number is not always conserved. I don't know why the slide is not telling you that, and I'm very confused. What is this slide trying to do? Yeah, it is possible that it is antiproton. It is possible. There is a lot of possibility. Really, there is a lot of possibility. There's a lot of possibility. The reason is because they don't explore with you a lot of rules. Right? Okay, so you are correct. You're correct. Currently, I'll tell you, okay, you're correct. Sorry. Okay. And finally, we talk about quark confinement. Dear. Okay, right. Okay, wait. Oh my goodness, that's not, oh, stop doing that. Okay, so the last thing to conserve is not the strangeness number, but the lepton number. The lepton number is the last thing to understand. It is just a vehicle for another rule that must be followed. That means the quarks must follow this. So we just follow that, right? So they give you the table for the lepton number, right? They give you the table for the lepton number, which is just here, right? Ainesh, are you okay so far?
I don't know what the answer for 7C is.
7C here. Okay, so just a minute. So kindly read page 103. I am just, I'm just going through the essence lah. 103. There's a new rule and we're gonna conserve the lepton number. So now C, yeah? Okay, Ainesh. Okay. Who sends out the mode? Yeah, okay, understand. Oh, right, okay, right. So he wants to know the guy with the most text message, correct, Ainesh? That's what he wants, right? Most number of text message, that's a term, is called the mode lah. The mode is just the most frequent number lah, right? The most frequent, in this case, the most frequent guy lah, right? That's the mode lah. So there is a form called what do you call it? There's a form called stem and leaf diagram. Do you know what that means? Does your slide cover stem and leaf diagram?
I've heard of it before. I don't know if it covers it.
Let me see whether it's present in the questions that you pick. It is not.
Oh, we did this at the start of the year.
Stem and leaf, yeah, because it's also not a very difficult thing. It is not. Stem and leaf is a possibility. It is possible to see the mode rather easily. There is another one lah. There's another one. It's called the cumulative frequency.
Okay.
For now, let's just ignore C, okay? Let's just ignore C because it suggests, means actually, I mean, it depends on my justification. It depends on my knowledge on the other thing. Let's get to know the other thing and then come back and justify ourselves. Understand? So I'm waiting to revision of stem and leaf. cumulative frequency, then you'll have a better, you'll be more equipped lah. Yeah, don't worry too much first. Can?
Yeah.
Before we end, can we try one more question, please? There's another box and a whisker, man. That's also a good thing. Okay, do simply make that bigger, okay? Do simply make, I made a duplicate page. So in the duplicate page, let's just delete the rest. Okay. Okay, move to the next question, move to the next question, and let's just do this question, okay? Yeah, that's the cumulative one. Okay, let's go. Ananya, are you okay with slide 98? Oh dear.
I know.
Right, and this is the 6 leptons, which are totally different from the baryons that we know, the hadrons, sorry, the hadrons that, I'm so sorry, I'm throwing a lot of, so do you know what's an hadron? Sorry.
No. Wait, what is the meson?
It's just a family name, lah. The baryons and the mesons. The baryons have baryon number 1, simple, the 3 quarks, right? The one consisting of 3 quarks. The mesons have baryon number 0, the one consisting 2 quarks.
Oh, okay.
Strange or not strange, there is no such particle that consists of 4 quarks and 1 quark. No such thing. No 1 quark, no 0 quark. That doesn't make sense. No, actually it does make sense. Okay, no 1 quarks and no more than 3. So just 3 and 2 lah. 3 is the baryons, 2 is the mesons. No, they keep it that way. They just group it as hadron, whatever, something like that. Okay, so leptons, I wonder, leptons is made out of how many quarks? Okay, how many quarks? The answer is lepton is not made of any quarks.
Okay.
I'm so sorry that is very confusing at the start. I'm so sorry, right? Okay, so we are talking about 6 leptons, and they are, if the 6 leptons, for all its worth, is more important than, is of the equal importance to the quarks we talk about. The difference is we have to memorize these 6 leptons. The same way that we memorize the 6 quarks, right? The 6 quarks, okay? We memorize the 6 quarks and we memorize the 6 leptons. There is a reason why we memorize them, because the quarks are foundational, nothing smaller. The leptons is also foundational, nothing smaller, at least as far as we know. Okay, that's why we just go and memorize them, because anything more complicated than that, we can just construct from the quarks or from the leptons. That's why we have a table for them. Will this be okay?
Yeah.
Okay, right. I am so sorry. Yeah, I'm gonna skip the next slide. Skipping the next few slides. Okay. Okay, right. So I will yeah, it's not gonna make a lot of sense, but we do have to memorize it, right? So I'm talking about slide 107. That will be what the final thing we need to memorize about leptons, because he's now talking about the conservation of lepton number. That's what we need. Okay, look at slide 107. Okay, bear with it for a while, yeah. Bear with it. Ainesh, are you okay with the new questions? Come, let's come.
It's on page 20.
Page 20. And you're not doing anything. You're just looking at it. You're not writing stuff.
Oh no, I'm still reading it.
Okay.
It's a lot of information to take in.
It is true. And this probability question is no joke one. No joke. No joke. No joke. It requires a lot of understanding of the question. It's not the it's not the topic, it's the question itself. Good tackle. Good thing to tackle. Okay, Ananya, any question for slide 107? Oh dear.
No, I think so.
Apologies, sorry.
It's okay. It's the same as baryons.
Yep, with the additional of whatever generation means. But he do tell you that generation 1 is the first 2, generation 2 is the second 2, and generation 3 is the second 3 lah. The total number of leptons in each generation must remain the same. Whatever that means, we're going to use that lah. Okay, so let's see. And the most important, one of the more important slides, which is slide 1. What is this? I'm sorry, I'm lost with the slides. I'm so sorry. Did I ask you to read 107 or 109? I'm so sorry. Which one? Which one did I ask you to write? To read?
107.
Oh yeah, correct. Then moving on to 109, which is a mass.
Yeah.
Can you look at the appropriate slide for 109? Is it possible to do that? If not, it's a bit unfortunate that we have to skip this because this is the practice.
I'm trying to send you the PowerPoint.
Can. Or you can just screenshot and put it in the Jamboard if you wish. That will also be helpful. Oh, you're writing something there. Okay, I didn't notice that. So Ainesh, how is it? Are you ready to write something or can I help you understand the question?
Hard. Yes, please.
Not everything, please. Ask your question. Not everything.
Just how do I start?
What do you mean by how do you start? Do you understand the question or not first?
What I'm doing, tell me if I'm on the right track here.
Yes, please.
So what I'm going to do is, for example, you see 0.052 or 0.994.
Sure thing.
So 0.05%, 0.994 plus, that's not right.
Okay, look at the Jamboard. Yeah, look at the Jamboard. So this is allergic blue, right? This is allergic red, correct or not?
Yeah.
All right. Not allergic blue, not allergic red, correct?
Yeah.
Okay, there are only 4 options lah. Keep it simple, right? No matter how complicated, it's just 4. Probability liquid turn blue means allergic blue and non-allergic blue lah. Correct? That's what it means, right? So you just add them up lah. Find your NB, find your AB, and add them up. Does that make some sense? It needs to make sense.
It makes
I'm
sense.
not teaching.
But how do I find AB and NB?
All right. So AB is very simple, right? First, I am allergic, which is 0.006 chance. And then I have 98% chance of getting blue. So blue allergic means 0.006 times 0.98, if that makes some sense. And just times, something like that. That also need to make some sense, right? Okay, Ananya, are you sending me something or showing me something?
I'm trying to skip to the slide.
Oh, no, you're sending me through email, isn't it?
No, I'm
You forget it.
trying to, because it's a PowerPoint, then like,
right.
I think it's messed up because of the transitions.
Correct. So the PowerPoint is not messed up.
Yeah, so I'm trying to like.
Good. Yeah. You can just look at it, but you can also paste it for me. But most importantly, you just look at it lah. If you don't understand, then you paste it for me. Right? Right. Okay. Yeah. So he. He really wants to tell you everything, is it? He really wants to tell you everything. My goodness. Oh, why do they do that? Yeah, he really wants you to tell you everything. Wow. Okay. Didn't expect that from SL Physics, but okay.
This is ridiculous.
Yes, Ines, you're saying?
Nothing.
Do you understand the B question, the given question?
Yeah.
Really? That's good. Really, if you understand it, that's good.
Yeah, I understand. I understand.
Wow. Thanks for the good news. Right.
Basically,
What?
like take the value.
Yes. If the value doesn't work out, then that thing it's not feasible. Something like that. Yeah, which kind of narrows down the candidates, which is what we're trying to do, I guess.
So if either barrier number, lepton number, or the charge number is not feasible, like if it doesn't work out, then the whole thing is not feasible.
More like everything must work out, right?
Yeah, okay.
Baryon, lepton, and charge must all work out. Then we have some sense of visibility, some sense. Okay, which is, yep, that's it. That's it. And we just use simple math to show it. So the slide 110 is just the same thing lah. So we are analyzing whether it works or not. Same thing.
Okay.
So would you give it a try? And I'm sorry. So time is up, but this is already some sort of example lah. Now I'm curious. I'm more curious about this. Have you reached this level yourself? Are we just repeating what you already know?
We've done this in school, but half my teacher went too fast, and then I also missed a lot of lessons during this chapter.
Oh, right. So there's something new today for you something new that you learned. All right, then we should call it a day, but you can try 110 first, and the rest will be confusing again. They keep wanting to dump you everything. So at least work this out, and then we can progress again. I am so shocked that they just want to dump you everything. Wow. Okay, yep. So I'll see you next Sunday, right? Yeah, next Sunday. Okay.
Next Sunday. The next 2 Wednesdays, I won't be able to make it.
Still seems okay for me considering your progress. That's okay.
Yeah, okay.
All right. I'll see you on Sunday. Bye.
Thank you. Bye-bye. Good night.
Good night. Okay, Ines, right. Okay, so you have a number and the number disappear.
I don't know what is going on. I'm so confused. I multiplied this, and then I multiplied this, and then after that I got AB and NB, and then after that I have to do the percentage of AB over AB plus NBR.
And you're correct.
I'm so tired from studying. Yeah.
This is frustrating. This is frustrating. I mean, you kept the hardest one at the end, not intentionally, but I wouldn't be surprised. But I say something positive here. Hey, you seem to be doing the right thing, even though you're very confused or frustrated by it. You seem to be doing it. You're just frustrated. That's a very big positive, considering that we almost never talk about this one. Considering that, to me, it's a big positive. Okay, right? So I think today's, this has been a long day, we can stop right now. I think you get a taste of. This is a very fair taste of WA3 and the final exam. This is part of a final exam. Correct?
Yeah.
For that, I congratulate you for having a good taste. Just left the circle and don't know why the vector question is not there. We still have to study probability. We still have to do that, but we'll do that. We'll continue doing that. Okay? Right. So, what do you want? What do you think? What do you want? Or maybe, how do you feel right now? Let's start with that. How do you feel right now?
Quite tired. I'm studying
Of
a lot.
course, of
Then I
course,
sleep. Then I went out, got a haircut.
of course, of course. Other than that, other than the feeling of tiredness, and of course you'll be tired, yes. Other than that,
Accomplished.
what does that mean to you? What does that?
And being able to do questions without struggling.
Sure thing. Right. I hope when you're not too tired tomorrow, you still have that residue of happiness lah. Because if you're not tired, you might be reasonably happy right now. You might be lah, right? Might be. All right. So tomorrow night you'll be leaving for the airport, right?
Yeah.
Okay. Now you make a decision lah. Tomorrow, do we still do some slots in the afternoon or not? Make
Oh
the
no, I'm
decision.
gonna be sleeping for so long because I usually can't sleep in the flight. So I'm gonna sleep as much as possible.
I hope you do lah.
Yeah.
All right.
I'm sorry, I just gotta get all the time.
No, 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 no. No need to be sorry. You make the decision. Remember, that is still true, lah, right? Okay. So now, that's it for this month, I guess. I will see you the Sunday before you start school.
Yeah.
Be there. Be there, yeah? Be there. Yeah. Same thing with your brother, lah. Okay.
Mm.
Good job. Have a good trip. I will
Thank
see
you.
you that Sunday. Bye-bye.
Bye bye.